everyone. My name is Richard, and today let's do some popular science, and it is delivered in English. And the topic today is gravity. We all know that gravity pulls us down to the ground. But how? People are asking these questions for centuries. And today, I'm going to tell you the history of gravity. It all started from an ancient Greek philosopher, Aristotle, 就是一个古希腊哲学家来说的 who had a lot of thoughts about our nature. 他对大自然有自己想法 and he believed that things fall down to the ground is due to their inner heaviness. 是它内在本身的一种重量让它掉下来。It is called natural motion. The idea is that, for example, fire and air tend to fly up to the sky, while water and earth tend to fall down to the ground. 就是火跟水飞是往上天上飞的，然后火跟气往天上飞嘛，水跟土往地上掉的，这是它的 natural motion. It seems plausible, right? 听起来很有说服力 ，but it is totally wrong. 全错。Then what is right? It comes to Newton. Isaac Newton is the first man who successfully found the secret of gravity. He formulated the famous law of universal gravitation by observing the motion of moon. 他就观察月亮，发现了重力的秘密 which is this law of universal gravitation is G, gravitational constant, 重力常数 times the products of mass and divided by the square of their distance. 就是 F 等于 G R 平方分之 G M N， 就是我们常讲的一个重力公式。But wait, what is mass? Newton is the first man who distincted mass from weight. 牛顿是第一个把质量跟重量分开的人，这个东西不容易啊。He defined mass as the quantity of matter. Mass is the quantity of matter. 质量就是物质的量，有多少量 ？Something intrinsic 是本质上的东西。While this equation said mass attract to each other, 质量互相吸引 and the force between them are proportional to the product of their mass and inversely proportional to their square of the distance. 跟质量成一成正比，跟距离的平方成反比，它的定义成这样子。Which means the greater the mass are, the bigger the force is. The bigger the forces are, and the greater the distance between them is, the smaller the attraction force between them are. 就是质量越大，吸引力越大，距离越远，吸引力越小，这是它重力的公式。And this equation, I think no one will doubt that is the famous equation for gravity. 它是一个全球最有名的重力公式。But it is not flawless. 不是完美无瑕。为什么呢 ？Something tricky happens to Mercury. 水星的进动，这个科学家知道，水星进动。水星的进动问题 cannot be solved by the mighty law from Newton. 这个 重力的牛顿的重力方程式啊，没办法解决水星的进动问题。So that lead us to Einstein. Albert Einstein. He approached this question in different way. He thought gravity is an illusion caused by space-time distortion. What is space-time distortion? This space-time distortion, 时空扭曲 like this. Imagine a flat carpet. I mean a magic carpet. 魔毯听过吗？飞在空中那种，很平坦。Then after putting some object on it, on the carpet, what will happen? 要选对不对？The flat carpet will curved, and it is all because of these objects. 时空的扭曲就像这样一样。This phenomenon can be described by Einstein's general relativity, which gives the famous tensor field equation, 张量场方程 called Einstein field equation, 爱因斯坦场方程。但这数学太难了。What is tensor field equation? It is a very difficult math tool that even I haven't learned before. 物理系、物理研究所都不会教这东西，你要相关专业才学得到。But we can somehow appreciate this equation without math. 我们可以去欣赏这个方程式，不需要数学。Really? Let's give it a shot. The fundamental idea is math tells space-time how to curve, and that curved space-time, in turn, 反过来 tells math how to move. 质量告诉时空如何弯曲，那弯曲的时空呢，反过来告诉质量如何运动。这个就是爱因斯坦场方程最重要的核心概念。Look at the yellow sphere. The mass of this yellow sphere or yellow objects curved the space-time nearby, 造成时空扭曲在附近。And then the gray little sphere just moved along the curved pathway around it. 这个就是爱因斯坦对重力的看法。他认为重力不是一种力量，是一种幻象，它其实是来自于质量对时空造成的扭曲。Einstein's general relativity theory leads a huge victory to the understanding of gravity. 它带来一个非常伟大的胜利，这是来自于重力的理解。It not only solved the Mercury precession, 它不仅解决了水星进攻问题 ，it also predicts some phenomena happens out there in the universe, like black holes and gravity dance, which have found recently. 这个黑洞啊，跟那个重力透镜啊，都是被爱因斯坦的小方程预言到，而且被发现，非常厉害。Physicists 物理学家们 nowadays solve the problem when by using Einstein's equation. When the mass or the speed are too big to use Newtonian mechanics. 物理学家解决问题啊，用爱因斯坦场方程解决问题啊，是用在质量很大、速度很快的情况上面。那这个时候呢 ，Newtonian mechanics 牛顿的力学无法使用。And scientists can predict by this equation the influence of gravity on Earth, Sun, or black holes, something like that, to the perfect accuracy. 这科学家可以利用这个公式去预测重力带来的影响到非常准确的地步。Okay, so now can we say that we actually understand the gravity? 我们现在可以真的大声的说我们了解重力了吗 ？Actually, no， 其实不是。Like I said, gravity, the gravitational constant is so small that we can that gravity is almost undetectable unless the mass is big, very big. 重力是很难被发现的，除非质量很大。But what about gravities between small particles? 当微小的粒子之间的重力该怎么办呢 ？Actually, no one knows what happened between these small particles. 没有人知道重力是在哪做的事情，因为质量太小。So in order to solve this question, physicists came up with quantum field theory. 这是量子场论，量子场论。Something related to quantum means very small. 只要跟量子扯上关系，就是很小的意思啊 ，very small. The idea is that all of the fundamental forces like gravity, 这些基本交互作用力，像重力 electromagnetic force 电磁力 and strong interaction, weak interaction 这些强弱交互作用力 acts through exchanging fundamental particles 这些基本交互作用是怎么样的？是透过交换基本粒子来去作用的。All the fundamental particles are found 所有的粒子都被找到了 except the one for gravity 只有重力子被找到。Scientists believed that graviton is the one for gravity. Okay. Yet it haven't found yet. 还没找到。So let's do a summary. We started from Aristotle's natural motion and Newton's law of gravitational force. Then we talk about Einstein's general relativity. The last is graviton. It is interesting that gravity is the first fundamental interaction that found by human. Yet it remains the least understood. 重力是第一个被发现的基本力，但是它却是我们现在最不了解的一个力量。It is amazing, right? 很神奇哦。But that is science. Now, can I answer your questions?